Okay, so up to last class, we have finished this resultant wave, intensity of resultant wave and everything. So Nabil, what are current sources? Nabil Khan. Current sources, Nabil. Yashika, what are current sources?
They're the sources which have same frequency.
Not just frequency. Frequency is least important. The most important thing is constant phase difference. Same frequency, same wavelength, and a constant phase difference. The sources emitting light of these types of lights are known as coherent sources. Okay. In this expression, this formula, R is a square plus b square to ab cos phi. Hishma, what are a, b, and phi in this expression?
So A is A and B are amplitude.
Amplitude of which wave?
Uh, Amplitude of the first and
Yeah, there are three
second.
waves basically. One is A and B are the amplitudes of two incident waves, and R is the amplitude of the resultant wave. There are three waves. Two waves, they superimpose and they form a resultant wave. So A and B is the amplitude of individual wave, R is the amplitude of resultant wave. And what is phi here? Noah, Noah, what is phi here?
So the phase difference.
Meher, how will you connect this phase difference with the part difference? Is there a relation between phase difference and part difference? Meher, what's the relation between this phase difference and part difference? Mehraj, what was the relation between phase difference and part difference? We discussed part difference in the
Sir,
last lecture,
tan
no?
tan
Yes, phase
sir,
difference and
tan theta is equal to b sine theta
no, no,
is
no.
b.
That's see, this is not part difference. There's no part difference here. Part difference and phase difference was this part difference is lambda by 2 pi into phase difference. That's the relation, lambda by 2 pi into phase difference, right, Alia? So we have discussed up to here. So this was Young's double slit experiment. Two waves comes from two different sources, S1 and S2. They superimpose with each other and they form a resultant wave. That was interference. Now let's discuss something else. Let's do one or two numericals based on this one and this formula. Here I1 and I2 are intensities of the individual waves and phi is the phase difference between them and I is the resultant intensity. So the first question is this. So you have two waves, their amplitudes are 3 Newton per coulomb and 6 Newton per coulomb. See, Newton per coulomb is the unit of electric field. So our amplitudes are electric field basically. The phase difference is pi by 6. First part, the phase difference is pi by 6. You need amplitude of the resultant wave. This is the formula that you use. So here A and B are given. A is given, B is given, phi is given. So you can get the value of the amplitude of resultant wave. Similarly, part difference is lambda by 2. So if you have part difference, you can get the value of phase difference and then also you can get the value of R. Do this numerical and write your answer in chat. See, the formula that you will use is this. R is a square plus b square plus 2ab cos theta. You have both a, b, and phi, value of everything. Note it down.
Sir, can you please repeat? I got disconnected.
Okay. So I was just repeating the things. This we did this thing in the last class, na? R, which is a square plus b square plus 2ab cos phi. A and b are the amplitudes of the individual wave, and phi is the phase difference between them. Similarly, this relation we derived in the last class. I1 and I2 are the intensities of the individual wave, and phi is the phase difference between them. So this is the numerical that you have solved. The formula that you will use in this numerical is the same, a square plus b square plus 2ab cos phi. Do it now. Solve it and write your answer in chat room. See, if you can't solve this numerical, then it's very tough to move forward. All other concepts that we'll do today will depend upon this numerical basically. Answers? Okay. I got answer from Noha, Arpit, Yashika. Answer of first part. Alia, Hishma, Miraj, Nabil. First part is straightforward. You have A, you have B, you have phi. Just substitute in that formula, na? A square plus B square plus 2AB cos phi. No answers. Okay. See, this is a formula based thing. Huh? A, B, and phi are given, and this is the formula A square plus B square plus 2AB cos phi. You just have to substitute the values. So see, the amplitude of the resultant wave is root over A square. How much is A? A is 3, so that's 3 square. B square, B is 6 square. Twice of AB, 2 into 3 into 6 into cos pi by 6. Cos pi by 6 is half. So this 2 and 2 gets cancelled out. So this is root over, see, this is 9 plus 36 plus 18. So this is equal to 45, 45 or 10, 55, 63 Newton per coulomb. That's the first part. Cos pi by, okay, this is cos pi by 6. Okay, okay. Cos pi by 6 is not half, it's root 3 by 2. Root 3. So this will be 9 plus 36 plus 18 root 3. So this is root over 45 plus 18 root 3 Newton per coulomb. Haji, Nabil, Hishma, is it clear now?
Yes, sir.
Raj? The formula based thing, now just substitute the value of AP in pi. Now see the second part. In the second part, instead of phase difference, part difference is given. So what you will do, you will first calculate the phase difference. How will you calculate the phase difference? Phase difference is 2 pi by lambda into part difference. This relation we did when we were revising basics of wave mechanics. So delta phi is 2 pi by lambda into part difference. Part difference is lambda by 2. When you substitute the values, your phi phase difference comes out to be pi. So you have phi, you have A, you have B. Repeat the entire calculation and get the value of R.
So can you repeat what we have to do?
You have to calculate the resultant amplitude. Resultant amplitude is A square plus B square plus 2AB cos phi. Phi is pi here. Just put the value of A and B in this expression. A is 3, B is 6, phi is pi. Yes, Noah, you're right. Saifullah is correct. Miraj, you're not solving, huh? Hishma, Alia, Yashika, where are your answers? Yashika, Hishma, are you solving?
Yes,
Yes,
sir.
sir.
No, it's wrong. Cos pi is -1.
I took -1 only.
Then it should not be this value. Just check your calculations again. Nabil, are you calculating it? No. Nabil, strong calculation. Cos pi is -1, yaar. Don't be this bad. Miraj is correct.
Yeah,
Arpit is
cos pi
wrong
is
again.
-1, right?
Yes. A is 3, B is 6, and this is the formula. 2AB cos pi. I don't know what you and Arpit are getting the exactly same answer, and it's wrong. It's wrong. Yashika, you're not in class, huh?
Sir, I am there.
You are there. Then why not calculating? Just straightforward calculation. See, the formula is a square plus b square plus 2ab cos pi, huh? Instead of phase difference, we'll use pi, cos pi. So this will be 3 square plus 6 square plus 2 into 3 into 6. How much is cos pi? Cos pi is -1. So this will be root over 9. Yes, Alia, it's correct. 36. 6 is a 18, 18 to the 36 minus 36. 36 will cancel this 36. It's root over 9. And how much is root over 9? That's 3 Newton per coulomb. Haji, Arpit and Nabil, why were getting -81? You both were getting minus of 81. What mistake
Sir,
was
I
made?
added 36 and 36.
Very
And sir, I then took the negatives.
great. And Nabil, you two were
Same,
making the same
same,
mistake.
same thing, sir.
So this is how we'll use this relation. Huh? So if you have individual amplitudes, then you can calculate the resultant amplitude. Similarly, if intensities are given, then you can also calculate the resultant intensity. Okay, can anyone, okay, just note it down. Then we'll do one more question. We'll make one more question out of it. Everyone is calculating now. Okay, so okay, instead of the amplitude, if I ask you to calculate the intensity, then what will you do? Yashika, for you. In the first part, instead of calculating the resultant amplitude, what will you do if I ask you to calculate the resultant intensity?
Sir, K times
K times, then
Sir, I is equal to K times amplitude square.
so resultant intensity will be K times the square of amplitude. So resultant intensity will be K times the square of this amplitude. So root over 45 plus 18 is 3 square. Similarly here, if I ask you to calculate the resultant intensity, that will be K times 3 square. 9. Is it clear? The relation between intensity and amplitude? Just note it down. Huh? These, instead of amplitude, if he asks you to calculate intensity, then you will use K. Don't worry about this K. If you have this numerical, then he will ask you to calculate the ratio of intensities. K will cancel out. Okay, next. The next task is the condition for maxima bright fringe constructive interference. Means everyone have written up to here? Nabil, Umar.
Yes, sir.
Okay. So see what we will calculate now. See, up to now, we have calculated the fact that if these are two sources. The two light waves are coming from these two sources. These two light waves will superimpose with each other. And after superposition, they will form some fringes. So till now, we don't have the condition for which we will get bright and dark fringes. We just have the equation of the resultant wave. We know the equation of the resultant wave, which is due to superposition of wave from these two sources. Now, what you have to do, you just have to calculate the conditions for the bright fringe and for the dark. So for the conditions of bright fringe and dark fringe, what we will do, we need the value of phase difference for which you will get a bright fringe here, and you need phase difference for which you get a dark fringe here. If you have phase difference, then you know the relation between phase difference and part difference. Using that relation, you can get the value of the part difference also. So first of all, we will calculate the conditions or the value of phase difference for which we get the bright fringe. Bright fringe means you get the maximum value of R. So this is the expression R is A square plus B square plus 2AB cos phi. So Nabil, what should be the value of cos phi for which this R is maximum?
Pi by 2.
No, the value of cos phi. What is the maximum value of cos phi? I'm not asking about the angle. I'm asking about the complete cos phi. What is the maximum value of cos phi? Arpit? Arpit, what is the maximum value of cos phi?
Sir, 0.
The maximum value of cos phi is 1. The maximum value of cos phi is 1. And when is this value 1? The value is 1 if your phi angle is 0, or your angle is 2 pi, or your angle is 4 pi, or it's 6 pi, or you can say 2n pi. So your cos phi is maximum if your phase difference is 2n pi. If you substitute n equal to 0 here, Hishma, what value you will get? If you put n equal to 0 here, what value you will get?
0.
If you put n equal to 1, then
2 pi.
if you put n equal to 2, then
4 pi.
so if you keep on changing the value of n here, you get all these values. So for the maximum value of R, your cos phi should be 1, which is possible only if your phi is either 0, 2 pi, 4 pi, or some 2n pi. This is the phase difference for the maximum R. Okay, instead of phase difference, if I want to calculate the part difference, know how, what you will do? We know phase difference for the bright fringe or the maxima. What you will do for part difference? How will you calculate part difference?
So we will multiply it by lambda by 2 pi.
Yes. Everyone is getting this? The relation between phase difference and part difference is lambda by 2 pi into phase difference. So for part difference, what you can do?
So can you repeat?
Yes. This is the phase difference. Huh? You
Yes,
need
sir.
part difference now. The relation between part difference and phase difference is this. Part difference is lambda by 2 pi into phase difference. How much is phase difference? It's 2 n pi. So instead of pi, you can put 2 n pi. So 2 pi will cancel out and you get n pi. So this is delta x, which is n lambda. So the part difference for bright fringe is n lambda, and the phase difference is 2 n pi. See, these different values of n represents different fringes. N equal to 0 represents central bright. Central bright means this one. The bright at the center is central bright. You get this when your n is equal to 0. For n equal to 1, you get the second bright. First bright, sorry. Then for next value of n, you will get another bright. So each value of n will represent a bright fringe. And this is the part difference, delta x equal to lambda, and 0 is 1 to n. Note it down. Then we'll calculate the maximum value of r. Ask again if you have doubts in it. If you still have doubts, Vishwa, doubts?
No, sir.
Shafula,
No, sir.
Nabil,
No, sir.
note it down. So these are the conditions for bright fringes in terms of
So what does fringes means?
fringes means spots only. Two lights combine and they form some bright spots and some dark spots. So the fringes means the spots only.
Okay, sir.
Can I scroll it if you have written up to here? Noah, Miraj, Arpit, Nabil. Haji, so everyone have written up to here? Arpit, written?
Sir, wait a second. Yes, sir.
Okay. Ishma,
Yes,
Nabil,
sir.
all have it. Okay. So these are the conditions of phase difference and part difference for which you get a bright fringe. So phase difference should be 2 n pi and your part difference should be n lambda. The next is you need the value of R, the maximum value of R. To get the value of maximum R, what should be the value of cos phi here, Noha, if I need R to be maximum? No, what should be cos phi if you want R to be maximum?
So cos phi should be 1.
And what should be the value of R then? So then R will be a square plus b square plus 2ab. See, it's a whole square of a and b, right? So for maximum R, you can just substitute cos phi equal to 1. See, you will put phi equal to 2 n pi, cos 2 n pi ultimately 1. So that's a plus b whole square. Square will cancel the root and you get R max equal to a plus b. Now, if you have R max and you want intensity, maximum intensity, then maximum intensity is just k times the square of amplitude. Maximum intensity is just k times the square of amplitude, k times a plus b square. That's the maximum intensity. Similarly, if I ask you to get the value of intensity, this is the formula of intensity. And I ask you to get the value of maximum intensity, then again, for maximum intensity, your cos phi should be 1. Bright fringe means amplitude is maximum and intensity is maximum. Here we calculate intensity in terms of individual amplitude. Now we get intensity in terms of individual intensities. Put cos phi equal to 1. Means you put phi equal to 2 n pi. When you put phi equal to 2 n pi, then it will be cos 2 n pi, which is 1. So it's I1 plus I2 plus 2 root I1 I2. And what is 2 root I1 I2? That's root I1 plus I2 whole square. So this is the maximum intensity in terms of individual intensities, and this is the maximum intensity in terms of the amplitudes. And this is the maximum amplitude. So the bright fringe that we are getting in this experiment, this bright fringe. So the amplitude of this bright fringe is a plus b. The intensity of this bright fringe is k times a plus b square or root I1 plus root I2 square. Note it down. Then we'll do the conditions for the dark fringe and then we'll start some numerical.
Sir, the lower intensity, sir, the formula which we did down. Sir, it was for which, in which terms actually? Sir, this is for a plus b.
Yeah, this is in terms of a plus b, means this is in terms of individual amplitudes. That I1 and I2 is in terms of individual intensities. The intensity
Yes.
I1 is the intensity of wave from the first source. I2 is the intensity of wave from the second source. Yes, can I scroll it now? Nabil,
Yes, sir.
write down the maximum intensity now.
Sir, IR and IMAX is not same.
Yeah, IR is the resultant amplitude. This IR is for any value of phi. But when you say that your resultant intensity is maximum, then that is for a particular value of phi. So IR is for any value of phi. But Imax is when your phi is 2 in pi. So this is resultant intensity, and this is the maximum value of that resultant intensity. That's it. Ishma, written? Miraj?
Yes, sir.
Okay. So that was the condition for the maximum amplitude and maximum intensity. Next is the condition for the minima or dark fringe or destructive interference. So minimum means the value of R is minimum. See, the value of R is minimum if cos phi is minimum. Miraj, what is the minimum value of cos phi? Miraj,
Sir, 1.
1. Maximum value be 1, minimum value be 1. बराबर है. Minimum value of cos phi. 1 is the maximum value.
-1.
Minus 1. Yeah. For minimum amplitude, your cos phi is 1. Okay. For what value of phi this cos phi is 1? See, if your phi is pi, means cos pi is -1, or it's 3 pi, or it's 5 pi. So all odd multiples of pi will give you -1. So you can write this as 2 and -1 pi. So phi is 2 and -1 pi in general. So if you start, and the value of n will start from 1. Your n will be 1, 2, 3, and all. So if I put n equal to 1 here, see, you will get 2 minus 1 pi is 1 pi. If you put n equal to 2 here,
3 pi.
3 pi, and so on. You just keep on changing the value of n, you will get all these values. So phi is 2 and -1 pi. Next, I need part difference. What the relation between phase difference and part difference? Omar, we know the phase difference, right? This is the phase difference. I need part difference. So the relation between phase difference and part difference. Mishma, relation between phase difference and part difference.
Path difference is lambda by 2 pi into phase difference.
Right. Part difference is lambda by 2 pi into phase. So if you put the value of phi, which is 2 and -1 pi, then it's lambda by 2 pi into 2 and -1 pi. Pi and pi will cancel out each other. It's 2 and -1 lambda by 2. This is the part. The part difference is 2 and -1 into lambda by 2. No. And the value of n will start from 1. Note it down. Then we'll do the minimum amplitude and the minimum intensity. A similar calculation. Haji, can I scroll it now? Meher, Ishma.
Yes,
Yes.
sir.
Okay, so after the part difference, we need the minimum value of the amplitude and the minimum value of intensity. So if this is the equation, for minimum amplitude, what should be the value of cos phi, Miraj? For minimum R, what should be the value of cos phi, Miraj?
-1.
-1. If you put cos phi equal to -1 here, it will be a square plus b square minus of 2ab. So instead of plus sign, see, phi, I'm writing 2n minus 1 pi. This is minus 1. A minus b whole square. Your r minus is a minus b. If you have r minimum, then how will you relate this r minimum with I minimum, Nabil? You have amplitude, minimum amplitude of the resultant wave. How will you calculate minimum intensity of the wave? Nabil Khan,
I equals K A square.
not a square, k r square. Na? So it's
Okay,
k times
KR.
r minimum square. And how much is r minimum? That's a minus k minus b square. So this is the minimum intensity in terms of the amplitudes of individual waves. You can do one more thing. Instead of the amplitude of individual wave, you can calculate the minimum intensity in terms of intensities of individual waves. For that, you will use this relation. Put cos phi equal to -1. This is this term. Arpit, can you write this as a whole square of something? I1 plus I2 minus 2 root I1 I2 cos phi. Arpit, can you
Yes, sir.
write this as a whole square of something, this equation? अरे
Sir, I1 minus I2 का whole square.
I1 minus I2 का whole square में रूट कहाँ से आएगा? No. It's I1 minus I2.
Root.
Root I1 minus root I2 whole square. So this is the minimum intensity. Note it down now. Note it down. So this R minimum is the intensity of your dark fringe. This is the intensity of destructive interference. Can I scroll it if you have written? Alia, Nabil, Umar. Have you written up to here?
Writing, sir.
Okay. After this minimum intensity, the next is the ratio of the maximum and minimum intensity. See, the maximum intensity is this K times A plus B whole square. This one. This here is the maximum intensity. K plus B whole square. And this is here the minimum intensity, K minus B whole square. So we can take ratio of them. So K and K will get cancelled out. So we take ratio A plus B whole square by minus B square. There is one more interesting thing. See, these are two slits. The width of the slit is W1 and width of the slit 2 is W2. We are talking about the width of these slits. These slits. Okay. These slits. I'm talking about the width of these slits. These slits width. So the hole basically, this is slit width, the hole that you made in this cardboard. So this slit width will decide the intensity of light. The wider slit will have the greater intensity of light. Obviously, more light can pass through it. So there is a relation between the slit width and the intensity of light that is passing through it, and that relation is this. Slit width W by 1 by W2 is equal to I1 by 2 intensity of light, which is equal to Ka square by Kb square. So Kk will cancel out, say square by B square. So instead of given A and B, see, we did a numerical today, na? The first numerical of the class where A and B were given. This one. A and B yeah, this one. A and B were given. A was 3 and B was 6. Instead of A by A and B, he can give you the ratio of slit width. The ratio of slit width will be equal to the square ratio of the square of their amplitudes. So instead of given A and B, he can give you W1 and W2. So yeah. So this one should remember that the ratio of width of the slit, width is this, okay? This opening is the width. This opening is the width of the second slit. The ratio of width of two slits is equal to the intensities, which is equal to the square of amplitude. Just note it down. We'll start doing numericals of it. Is it clear? Noah, Saifullah, Hishma, Arpit,
Yes, sir.
or still have doubts? Nabil, any doubt in this section?
Sir, can you explain the ratio part?
Yeah. See, the ratio of, see, you have this slit. This is slit 1 and this is slit 2. So the width of the slit means this one, W. The width of the slit is W2. This is W2. So the intensity of light that is coming from this slit and the intensity of light that is coming from this slit, the ratio of intensity of light is equal to the slit width exactly. And intensity is K times square of amplitude. So you can connect the slit width, the intensity of light coming from that slit, and the amplitude of it coming from this slit.
Okay, sir.
So numericals, instead of A and B, instead of I1 and I2, he will give you W1 and W2. So from W and W2, you have to relate A, B, I1, I2. Ajay, can I scroll? Raj, written up to here? यही निकला। Nabil, Arpit.
Yes, sir.
Yes, sir.
So this is the question. See, ratio of light from two coherent sources are light phase A and 2A. Ratio amplitude of light from two sources are A and 2A. For the first source, the amplitude is A. For the second source, amplitude is 2A. So instead of A, it's A. Instead of B, this is 2A. You need the amplitude of maxima, you need the amplitude of minima, and the ratio of intensity of maxima and minima. Do it. Do it fast. Instead of A, you have A. Instead of B, you have 2A. Just get the maximum and minimum amplitude. Your answer will be in terms of A only. Do it fast and write your answers in chat room. Okay, Arpit. Yes, right answer. Arpit, just calculate third part also. Huh? Answers, Hishma, Saifullah, Nabil. This is a formula-based thing. I just want to check whether you understand the basic formula or not. Meher, Saifullah. No, I think. Okay, yes, Ashma, both are correct. Now the third part. Nabil, answers, Umar. Nah, no, Arpit's wrong. Stronger. Yashika, Noha answers. No, Arpit. Arpit, intensity and amplitudes are square of each other. Like intensity is square of amplitude. What are you doing? Noha, there's no need to write minus here. Subtract smaller from the greater one. So there won't be a negative sign. Yashika, your answers? What happened, Yashika? You're not calculating today, huh? Saifullah, Alia. Nabil is a formula-based thing. Okay, first part is correct. Second part, Saifullah. Nabil, at least send the answer of one part. At least send answer of first part. This is A, this is B. He's asking about the amplitude of maximum. Saifullah, there's no need to put negative sign here. Subtract smaller from the greater one. So instead of doing A minus B, you can do B minus, you know. Nabil, are you in class?
Yes, sir.
Did you
So you have to
calculate the
solve
first?
IMAX.
Yes, not I max. The first part amplitude is saying, na? R max. Yes, Yashika, first is correct. What about second and third part? Noah, third part is also correct. Good. Yes, Yashika, second is also correct. I'll do the third one. Alia, your answers. Meher, your answers. Omar. Omar, you are not calculating. Yes, Yashika, it's correct. Yes, it's 2a. It's not a square, Meher. It's 3a. See, R max is a plus b. Now, so one is a, another is 2a. So that will be 3. This is the formula of R max, right? R max was a plus b. So it's a plus 2a is 3a. In the second part, R minimum. R minimum is a minus b. So that's 2a minus a. It's a. In the third part, the ratio of I max and I minimum. For the ratio of I max and I minimum, what we will do is, if you can check the previous calculation, this was I max by I minimum. It is a plus b square by a minus b square. So you can write I max as a plus b square, I minimum a minus b square. How much is a plus b? It's a plus 2a. How much is a minus b? A minus 2a, or you can say it's 2a minus a, greater minus smaller square. Although there is a square, so this negative sign will not matter. So that's 9a square. In denominator, you have a square. It gets cancelled out. You get 9 by. Haji, is it clear now? Nabil, Hishma is not also. Hishma calculated first and second part.
Yes, sir.
Is
It's
the third
clear.
part clear now? Okay, good. Note it down.
Yes, sir.
This is simple formula based thing. Just to remind you the formula. Okay, if you can do this question, then you can do this question also. If I- Do this one, next one. Do next one also and write your answer in chat. Okay, Noha got some answer. Noha, I don't think you are right. Nah, Noah, wrong. Think again. What is 9 by 4? No, Nabil, it's wrong. It's wrong. What is 9 by 4, Noha? It's wrong. Yashika, your answer. No, no, Yashika. Yashika, you don't have to calculate the ratio of individual intensities. You need ratio of maximum and minimum. Yes, Meher. Meher is correct. It's minimum and maximum. Yes, Meher is right. See, take your calculation. See what is given here. A simple sa question. Hai. See what is given. Slit width is given. Now W1 by W2 is given, which is 9 by 4. And you should remember that 9 by 4 is not the ratio of amplitude, it's the ratio of square of amplitude. See, we wrote this here also. So from here, yes, Hishma, you are right. We can write that A by B is root over 9 by 4, right? So from here, you can say that A by B is 3 by 2. So you can say, since ratio is given, you can say, okay, if your A is 3x, then your B will be some 2x. And we know the ratio of minimum and maximum intensities. We used this formula in the last class, last numerical also. It was maximum by minimum is a plus b by a minus b. So it will be a minus b whole square divided by a plus b whole square. So how much is a? A is 3x. What is b? 2x whole square. How much is a? 3x. How much is b? 2x. X square. Then this is 5x whole square. Then this is 25x square. Then this is 1 by 25. By 25. This is the ratio of minimum and maximum intensity 1 by 3. Note it down. Is it clear now? Noah, Nabil,
Yes, sir.
the mistakes that you people were making. Note it down.
Sir, I
We'll do
took 9 as A and 4 as
no,
B.
no. I took 9 as a square. See, 9 by 4 is equal to a square by b square. So a by b is 3 and width is not is equal to the square is not equal to the ratio of amplitude. Width is equal to the ratio of square of amplitude.
So from where X came from?
Since it's a ratio now, so I can't write that a is 3. So I write a is 3x, b is 2x. This is how we write if you have ratios. Because ratio of a and b is 3 ratio to 1. So I know that a is 3 times of 3x and your b is the ratio. Okay, let's do the next question. Let's increase the standard. Next question will be a bit tricky. Yes, if you have written, can we scroll further? Aji, can I scroll it now?
Yes, sir.
See the next question. Note down the second question. Young's, when you say Young's double slit experiment, that means intensities is same. I1 is equal to I2. Both the slits are identical. In original Young's double slit experiment, Young's took both the slits as identical. Write down the question. At least try to write down the given terms. What is lambda? What is k? What does lambda by 4 means? At least note down the given term. And try to identify the formula that will use for the unknown. Although I will solve this numerical, but at least you write down the given terms. Just try to think of a strategy to solve this numerical. Try to find out the terms that you are supposed to calculate.
Sir, part difference is lambda by 4.
No, it's yes, in the last it's lambda by 4. Right? Here it's lambda and then it's lambda. Try to think what is k, what is lambda by 4, what you have to calculate. See, in wave optics or in interference, questions of interference and diffraction, whenever path difference is given, the first thing that you should do is you should calculate the phase difference straight away. If you have path difference, first of all, calculate the phase difference, and then you will proceed. So, in Young's double slit experiment, intensity of light, Young's double slit experiment means I1 is equal to I2. Both are identical. Part difference is lambda, delta x is lambda. What is this k here? Yashika, what does k here means? This k. What does k stands for? Noah, what does k stands for? Saifullah, what is k here?
Lambda.
K can't be lambda. What is k? I'm asking about k. See, here, this k is the light at a point, intensity of light at a point. This k here is your resultant intensity. Okay. Now, if you have part difference, you can calculate phase difference. What is phase difference? Phase difference is 2 pi by lambda multiplied by part. So the phase difference, you can write it as by delta phi, or you can write your phase difference by phi. So your phase difference is 2 pi by lambda into part difference, which is lambda by 4. It's cancelled out, so it's lambda by 2, pi by 2. So this k is the intensity of the resultant wave. Okay, Arpit, now do you remember a formula for Hishma, do you remember any formula for resultant wave, resultant intensity in terms of the intensity of individual waves? Any formula where you can calculate the resultant intensity in terms of intensities of the individual wave? Hishma, IR in terms of I1, I2.
So I1 plus I2 plus 2 root I1 root I2 into cos I.
This is the formula that 2I1, I2. Next, what you can do is you can just put the value of IR. How much is IR? IR is K. And both I1 and I2 are equal. So instead of I2, I'm writing I1. So I1 plus 2 root I1. Root I2 is again root I1, then cos pi by 2. See, cos pi by 2 is 0. So this term will be 0. So yours K is 2I1. And you can write that your I1 is K by 2. So you have the intensity of individual waves now. So in the first part of the question, and obviously this is equal to I2, both are equal. So in the first part of the question, resultant intensity was given and you were supposed to calculate the individual intensity. So we get individual intensities as K by T. The next part is you have to find the resultant intensity at a point where part difference is lambda by 4. Now, since you know the value of I1 and I2, it's K by 4. You're supposed to calculate again the resultant intensity, but now part difference is not lambda, part difference is lambda by 4. So now what we can do is, we'll use this relation, we'll use part difference equal to lambda by 4, we'll calculate the phase difference again. Then just, sorry, I took the wrong way. Sorry, Initially, the part difference was lambda. Nah. Part
We
difference is
already used lambda by 4.
Lambda is the wrong. Nah, it should be lambda. So this is 2 pi. This is 2 pi. Cos 2 pi is 1. So this is 2 to 4i1. This is 4i1. This is k by 4. I1, I2, both is equal to k by 4. Now, you will calculate the resultant intensity, but part difference is not lambda. Part difference is lambda by 4 now. You know I1 and I2, it's k by 4. Then you can calculate the value of phi. Note it down. Repeat the calculation and tell me what will be the intensity if part difference lambda by 4. So I'll solve the 50% of the question. Rest you will solve. Do it. Okay. Good, Nabil. Right. Correct answer. Yes, Meher, it's correct. So I got just two answers, Nabil and Meher. Noah, Yashika, Ishma, Saifullah. Answers. Yashika is correct. Noha, Ishma, Meher. Okay, Meher already given. So Hishma is left, Saifullah and Noah. First, get the value of phase difference, then put that phase difference in this formula. You will get I1 plus I2, and I1 and I2 are both equal to. Okay, this is the solution. Okay, so this was about this bright and dark fringe of interference. There's the next part of interference is you have to calculate the width of the fringe, and you have to calculate the conditions for which you will get again the bright fringe and dark fringe, not in terms of phase difference and part difference, but in terms of actual separation. So I believe we should start in the next class. So everyone have written up to here? Kishma, Safullah.
Yes, sir.
Yes, sir.
Yes, sir.
So that was the first part of the interference in which you calculate the conditions for the bright and the dark fringe. The next is the theory of interference fringe. Here you will calculate the actual width of the fringe. You will calculate the conditions for which you get bright fringe or dark fringe. But now conditions will not be in terms of phase difference or part difference. Your conditions will be in terms of separation of fringe. So it's a small topic. We'll try to finish it in the next class. So let's stop it here only. On the next week, we'll be starting. We'll try to finish this up. Okay, so let's stop here. If you have doubts, we can discuss. Otherwise, I'll leave.
Sir, these notes are available on that link.
Yes, yes, that's available on that.
Sir, under which topic? Like,
Just let me check. These notes are
sir, it's only there till AC chapter 7.
wave optics. These are under wave optics.
Sir, that's not uploaded here.
Not uploaded yet.
Yeah, I can see only till 7 AC. Chapter
7
7.
AC. This EM waves, modern physics, and wave optics are not able to see them.
Yeah.
Okay, I'm sharing the link again. Maybe it's this problem with the synchronization.
Okay, sir.
I'm sharing the link again. So I put the link in the chat.